Hello,
Hello.
how's it going?
Hi. How are you?
Yeah, everything is good.
Yep.
What time is it at your side now, if you don't mind me asking?
It's around 3 in the afternoon.
Okay, so you're on the west side?
East Coast.
Okay, okay, cool. Okay, so before we start, if you don't mind telling me a little bit about like your experience and what do you want to get out of this session?
Yeah, sure. So, right now I'm interviewing for a software engineering new graduate position at Facebook.
Okay,
Currently passed the first technical round.
yeah,
And yeah, I basically have gotten invited to the a follow-up technical round similar to the first round where it's I think one 45-minute session where they ask around 1 2 coding questions.
yeah.
And yeah, my goal here is to basically to just maximize my chances of moving forward and passing this interview.
Okay, that sounds good. So I see that the session is marked as basically mentorship. So when I
Hmm.
do mentorship, it goes all the way from me basically solving problems and telling you how I solved it, all the way
Okay.
to actually me doing like almost a mock interview, similar to what you would face in Facebook or any other company,
Hmm.
or it can be anywhere in between. So what pace do you like, or like which direction you want to go?
I think the former, where I guess you kind of walk me through what I should be doing. I guess like give some of your advice, tips
Okay,
from whatever experience you have.
so how about we do this? Basically, I give you the questions and you start on them. And basically,
Hmm.
I give you like hints all over the way. So I will let you try first on something, and then I tell you like, okay, this is the way it should be done, or you should have done this differently, things like that. What do you think?
Yeah. Yeah, I think that's good. And then I was just wondering if I would be able to ask any questions about the process or whatnot.
Yeah, you can ask any question. I will leave like few minutes at the end, so you can ask any questions.
Okay.
Uh, but yeah, which programming language do you want to use?
Uh, Python?
Okay, let me just copy. So initially, just to get things going, I would
Hmm.
like to start with like a very like simple question that basically just to get things rolling. Let me just copy it and paste it here. 1 second. Yeah, this one.
Okay. So, given an integer array nums of length n, you want to create an array answer of length 2n, where answer at index I is equal to nums at index I, and answer at index I plus n equals nums at index I for the range of 0 to n, where I is always less than n. The answer is nums.
Do you understand it?
Uh, yeah, I'm still trying to understand it.
Yeah. So the first hint I would give you is basically when you get a question,
Mhm.
sometimes many interviewers intentionally leave the question a little bit vague.
Okay.
It's not like they forget to give you an example or stuff like that. They intentionally doing that. And the reason is
Mhm.
they want to see like how much you would actually chase down. Like one of the red flags that we see on interviews are
Mhm.
people who start solving a problem that we know that they don't fully understand. This is one of the
Okay.
very, very flags. So the idea here is that I do this personally, and I know many people who do that, that we
Mhm.
intentionally give a problem that may be a little bit vague or like has like wording that could allow to go both ways. So the first thing that
Okay.
you can do is you need to ask questions and you need to ask for an example. And
Okay.
once you are given an example, you would build your own example and ask the interviewer, okay, this is what I understand, and this is
Mhm.
the example I built. Is this correct? And once the interviewer say yes, you're right, okay, you can now
Mhm.
start solve the problem.
Okay. Yeah, that's kind of what I did in my first interview. Basically what you said, and then um, I also tried to give like I gave a couple of examples like edge cases and yeah, just to make sure I kind of understood the problem. But yeah, I guess the interviewer didn't. It was a little more specific than this. It wasn't this vague, but yeah, definitely good to know.
Yeah.
Um,
So what does this problem mean? Imagine
mhm.
that you have array A equal 1, 2, 3. We want the array answer equals 1, 2, 3, 1, 2, 3. So this is basically what we wanted.
Okay. And the input's just array A in this example, like here.
Yes, and it will have like one or more items, so it's never an empty or anything like that.
Okay. Um, so basically, the output of the array will be uh the output of the array will be size 2n, where n is the size of the initial array.
Yes,
Okay, and it'll basically repeat all the elements. So is it okay if I demonstrate with a few examples
yes.
to make sure I
Go
understand?
ahead.
Okay.
Yeah.
So if my A is oh, one, so this is my A, then would my answer output be something like this? So is this a valid example?
Uh, yes, exactly.
Okay. Um, so 2n, and sorry, you said no empty input is will be
No,
given?
yeah, input would always have something.
Okay. Input. Um, are characters or I guess numbers, sorry, allowed to be repeated? So can I have an instance where it's something like um 1, 1, 3, 4, 4, like that? Is that valid input?
Yes, it can be anything.
Okay. And is there a sorted order or anything, or is
No, it's just like you need to just repeat it whatever the order is.
okay? Um, in that case, I think just like a naive solution I would come up with um, would basically be uh, we iterate through array A, our input array,
Hmm?
um, A, and we basically have an output array where um, uh, we look at each element and output that uh, number into or add that number to our output array, and
Hmm.
then we could store that iteration in a while loop conditional, so we can repeat that process 2 times to satisfy the 2n condition. So
Okay, that would solve it, but can you do it in
okay,
one iteration?
in one iteration, I
So the
think I
third
could.
tip
Sorry.
that I would give you is
Mhm.
basically when you are given a problem statement, just pay
Mhm.
a very pay close attention to every word in that statement because sometimes the solution is there. Because if I selected something like this, do you see my selection?
Yes.
Okay. So if you look at this part,
Mhm.
it will tell you how to do it in one iteration.
AI. Oh, okay. So we just create a so I guess this would be the key conditional or
Mm.
function where I guess we would have to initialize our list so that it's has two n elements, and then for each index uh we and index for the output array at I, we update it with the corresponding variable value from our input, but
Yeah.
then we have to update it simultaneously with at index I plus n, since it's 2n, so the length of the array is 2n, so it would be uh, n distance from the index, and that
Yeah.
would
Exactly.
essentially give it twice.
Mm.
Okay.
So
Yeah, thank you
can you
for that. That was a very
yeah.
useful hint.
Yeah, like one of the things that we also do a lot is we sometimes give problem and there would be just a single word in that problem that means everything. So they will say something like you have a sorted array, you have a
Mhm.
complete. So this word sorted, complete, stuff like that, it is extremely important. That's the difference between making a solution that's n squared and a solution that's like n or log n. Just this word. So that's like something that also you need to pay attention because many interviewers intentionally do that. They put that word to make
Mhm.
sure that you actually pay attention to details.
Got it.
Yeah. So can you implement it?
Yeah. Um, I can. Is it okay if I code it out?
Yeah.
Okay. So we can have an output list, and I guess we can initialize this by um, I in range the size of our input array, and we could just initialize everything to 0 just for simplicity's sake. Um, so output. And then our real function will begin here. So for item in array A, our input array, we um, basically add at index, or actually it's better if I use the range function in this case, since we want to be able to go through the index of our output array. So for I, range length of our array again, um, I output array at index I is equal to our input array's value at index I, and then output at uh, array at index I plus length of array is equal to uh, the same value as well. And we would return our output array. So yeah, I believe the time complexity of this problem would be O of n, since we're iterating through the entire input array here. It would be technically n plus m since we have to initialize it here, but in the grand scheme of things, it's still big O of n.
Mhm.
And
Why did you need to initialize it to 0? Do you need that?
um, I believe I need it because um, without this initialization, it would return an index out of bounds error.
Okay.
in
I'm not.
Python at least.
Yeah, you cannot in Python like set the size initially without needing to initialize it.
I don't believe so.
Okay, sounds fine. Yeah, I'm not very proficient in Python myself, but yeah.
Yeah, it's not. I know in Java when you declare the size in an array, you initialize the size.
Yeah.
I don't.
In any
Yeah,
strongly typed language, you can set that, but I think, yeah, for scripting
yeah,
language, this might be the case. Okay, sounds
yeah.
good. Well, the code is clean. Um, yeah, this problem doesn't need that, but usually at this stage, what you do is
Mhm.
basically test your solution and basically trace it with examples. So we have a couple of examples above. You can walk through them, but we don't need to do this because this one is very simple. But
Okay.
usually, like a problem like this, you need to trace and make sure that your code work before you tell the interviewer that you're done. So after you finish implementation, you would say, okay, I think I'm done. Just give me a minute. I need to test it. And then you walk through the test cases. And
Mhm.
that's also one thing that interviewers do. Like, can you test your work or not?
Okay. So I have a question. So if I'm doing that and then I realize there's an error in my code,
Hmm?
do I explicitly articulate that to my interviewer and saying, "Oh, I found
Yes,
a bug or
yes,
an
yes.
issue"? Okay.
Yeah, so as interviewers, like I would never expect someone to write a code that's error-free.
Okay.
Okay, it is extremely well perceived if you are the one who found that error, because it means like you will never find a developer, no matter what their experience level is, that they write good bug-free code. It never happens because we are humans. Humans make mistakes, and the idea of you
Right.
being the one who finds that mistake, that's a very big plus.
Okay.
So let's
Yeah.
give you the problem. Uh, this one is a little bit harder.
Okay. You're given an array rectangles or rectangles at index I, with two left index. Okay. Length I, Li is equal to length and width I, Wi is equal to width. You can cut off the ith rectangle the first square. Max one B side. Okay, so in this given example, we're given this two-dimensional array for input, and our output value is 3, and this is because the largest squares you can get from the rectangle are of lengths 5, 3, 5, and 5.
Mhm.
Um, Largest possible square of length 5, and you can get out of get out of 3 rectangles. So in this problem, are we basically using rectangles to build and identify squares?
Yeah, so you will be giving like different rectangles. So
Okay.
what is the biggest square that can fit into a rectangle? So each rectangle you will get the biggest square, and then you would return the number of the biggest square. So if we look at this example, you have the first
Mhm.
rectangle 5 and 8. That's width and height. The biggest square that can fit here is 5 by 5. And then like 3 and 9, the biggest one that can fit here is 3 by 3. Then 5 and 12, the biggest is 5 by 5. And then 16 and 5, the biggest is 5 by 5. So we have 5, 3, 5, 5. The biggest square here size is 5. How many of that? 3. So here's the output that I want is 3.
Um, I'm sorry, could you explain this last part? I'm just confused. So I understand that so this is a list of rectangles. So
Yes.
each rectangle, we have to find the largest square we can make. So
Yeah,
that's kind of bounded by the smaller side since you're limited
exactly.
by the smaller side.
Yeah.
Um, so then we return an array which indicates the largest square for each
No,
rectangle
we
in our
don't
input.
return. We just return the number of the biggest squares. So if you have like, let's say that your solution is actually like this. So it is 5, 3, 5, 6. Then you return 1. The biggest square here is 6. How many 6s do you have is 1. So you just return 1. Now we have
Okay,
5, 3, 5, 5. So the biggest square is 5. How many 5s you have? You have 3. So you return 3. And so on.
got it. So basically, when we get to this stage, we want to one, find the maximum value and count the number of occurrences of that maximum value and return that as our
Exactly.
output.
Exactly.
Got it. Could I just add a few more examples just to make sure I have a solid
Yeah.
understanding of this problem? Okay. Um, so input, we have an input like this. Um, oh yeah, is all are all the inputs having a value, or can you have an empty input, if that makes sense? So like an input like this, and then like would this be a valid input or no?
No, there are always rectangles.
Okay. Um, and is the minimum size of a rectangle 1 by 1?
Yes. It will not be a
Okay.
rectangle. It needs to have like different length and width.
Okay,
But
so okay,
it doesn't really matter because yeah.
so
But
the length and width, sorry,
it can't be zero. It needs to be a positive
it
number.
can't be 0. Okay, so it has to be a minimum of 1 and they have to have differing lengths
Yeah.
and width. Okay.
And they are all integers, so there is no floats or stuff like that.
Okay. Trying to think if I can consider any other edge cases before um,
Yeah, there will be at least one rectangle, so you don't need to worry about like empty set or anything like that.
okay. So I guess this is the minimum size input, so 1 by 1.
Yeah.
Okay. And then in that case, I guess our output would be something like uh
One.
1.
Yes.
Okay. And then I guess that middle array would be 1 as well, since it's the
Yeah.
largest square. Okay. Um, or I guess that would yeah, sorry. I meant to, because I know they can't have the same value. Um, okay, yeah. So I think a my initial solution would basically involve iterating through our input list of rectangles
Mhm.
and um, basically and then having an output list where we store the data and um, basically checking to see which value is smaller since that'll determine whether the largest size of the square in each
Mhm.
rectangle. And we basically add that to our output list.
Yeah.
Um, and after we get our output list, we check to see, we find the max value of the output list, and then we count the number of occurrences in our output list of that maximum value, and then that's our final output.
Yeah, that would work. What is the complexity of that solution?
Um, that would be, so let me just write down these steps first.
Yeah.
Iterate through input array, then um, then find value, max square value, and find and then I guess return that. So these are the main, like, main parts of our function.
Yeah.
iterating through the array would take O of n time, where n is the number of rectangles. And then finding the max value would be, I believe, if we're using a binary search, it would be something like log n. And then I guess the last part would be find the number of occurrences of the max value, which would also be n, because we'd have to, in the event that's the entire array, or yes, it would be n.
Okay. So you would
So
be
you would,
doing, yeah.
sorry, I
Okay.
was just gonna
Let,
say, yeah,
yeah, that sounds fine.
yeah.
Let's experiment that.
So I guess our overall time complexity would be n.
And what is the space complexity?
Uh, Space complexity would be, um, I think n, since we're storing the number of rectangles in that output array, which stores the values of each,
Yeah.
the max value square. Yeah. Um, yeah. Is it okay if I code that out?
Yeah. Let's code it and see.
Okay. Um, array. So for rect in array, we let me initialize an output array. So for each rectangle in our input array, we if output array or dot zero is greater than output array one. So basically we're comparing the length of each rectangle to the width, and
Mhm.
if we if our length is greater than the width, sorry, then we add that to our, I'm sorry, I meant to put a rectangle here.
Yep.
So if our length is greater than our width, then we add that to our output array. And rectangle zero, and otherwise, well, we know that they have to be differing values, so we don't need to check. Or I guess we could say if rectangle at one greater than, so if our width is greater than our length, then we add
Mhm.
that to our output array.
Yep.
And otherwise, we throw an error because they are the same length.
Yeah.
Return, we can just say false for now.
Okay.
So yeah, this first part will basically go through our input,
Mhm.
check to find the smaller value if it's either the length or width, and then add that to our output array, which will store the max square for each rectangle. So then we have to do the second part, which finds the max square value. Python has a built-in function to do this. Is that okay to use?
Yeah.
Okay. So we just have max val is equal to max of output array, and this will basically store the max value, and then we do that final search to return the number of instances. So I could just let me create output variable, which is basically a counter.
Mhm.
So we could do a simple search. So for um, I in for val in output array, we would if val is equal to output array, we return or we increment our output value, and our final output would be the value of that.
Yeah.
Yeah, so yeah, just walking through, I guess we can walk through an example. So going through the first example, let me just copy the input and output just to make it a little easier. Um, okay, so starting with our input, so we first check, we have our initialized values here, and then for each rectangle, so each pair here, we check to see if the length is greater than the width. And if that's the case, then we add this to our output array list
Mhm.
over here. If it's the width that's greater than the length, then we add that value to the list. And if they're equal, in this last case, then we return an error because they have to be differing values. So we do that for each rectangle. So our output array should look something like this. Output array at this point would be 5, 3, 5, and 5.
Mhm.
So knowing that this is our output array, we find the maximum value, which would be 5. And after that, we iterate through our output array one more time just to see the number of occurrences of the max val. Oh, I found a bug right here. So this has to be max val since we're
Yeah.
comparing it to the max val we found here. And then yeah, if it's equal to the max val, we update our final output counter, which we declared over here, and we return that counter as our final output.
Yeah. Yeah, that's actually correct. So one more thing, can you make it work without using extra memory?
Okay. So avoid using this is probably our biggest bottleneck. Um, I think one way I was considering going about this um, is, I guess, using just updating the values of the input array.
Mhm.
So what we could do is if we could, I think, even avoid one of these conditions. So if our width is greater than our
You
length,
you
or
don't
I
need
believe
to
length
change
is a,
you don't need to change the input array. Like I would give you a hint. All what we need to care about is just the biggest number, right? We don't care about the smallest number, right? Or
don't we care
we
about the
don't we
small
don't
one?
we only care about the occurrence of the biggest square, right? So if we
Yeah.
maintain what is the biggest square in each step and maintain a count on each step. And if we find the biggest square, we reset and increment. So basically, we don't need to store everything, right? So let me
Yeah.
tell you what I mean. So you here have a variable called output, right?
Mhm.
And you have a variable called maxval. If we put maxval here and we
Yeah.
initialize it to next 1, and all what we need to do is in this for, we would do something like check if uh like rect here, rect 0. So instead of saying this, we would say rect 0 is bigger than rect 1. We would say if rect 0 is bigger than xl, what we would do is basically saying xl equal rect 0 and output plus or like plus equal 1. And here as well, we would say something uh, greater than max val. Actually, this one is equal 0. Sorry, equal 1. And here we would say else rect 0 equals max val. Then we would say output plus. And we do this exact same thing here
Mhm.
as well. And that's it. So basically, on each step, we get the bigger side, and we see if it is bigger than maxval, we set maxval to that side, and reset the output to 1. If it is equal, then we just increment. And by the time the loop is done, the output would contain the maximum number. So let's go over here. So you have 5 and 8. The, the,
Yes.
the, the, the minimum here, we actually need to have the minimum, not the maximum. So it needs to be like this. Uh, if yeah, we need to have the minimum side, not the maximum side, because it needs to be on
Mhm.
the minimum. So 5 and 8, the minimum is 5. So we would see, is 5 bigger than max val, which is -1? Yes. So max val would be 5 now, and the output would be 1.
Oh,
Next,
got it.
it would be a 9. 3 would not go through this, so nothing would happen. 5
Yes.
would go through the equal part, so it would be 2. And this 5 would go to the equal part, this would be 3. And then we would output 3.
Got it.
And then we just like iterated once, and we didn't use any extra
Mhm.
memory. But the first
Yeah. So you
solution,
avoid.
yeah,
Sorry.
this is
No, I was
more
just gonna
like,
say
yeah, avoided
you
using
just
extra
avoid this
memory,
whole thing. Yeah.
yeah, and didn't need this one as well.
Yes.
The first solution is just good enough for the interview. This one is like the extra. So this one like is a
Okay.
super good solution. We have time. Let's have one more problem.
Okay.
Uh, just try to find it. Yeah, this one is a little bit hard, even harder than this one. So it's totally
Okay.
fine if you find it hard to solve. I can help you with that. But it is good to give you like a hint of how the problem would look like. And this also
Mhm.
use what I gave you in the first uh, question. There is one keyword in this problem that makes all the. There is a very easy solution for this problem that you can go to. It will solve
Mhm.
it, and it's extremely easy for like if you know how to deal with a tree, you can solve it. But there is like a very optimized one that's based on a single keyword in the problem statement.
Got it. Given the root of complete binary tree, complete binary tree. So, would you be able to give an example of a complete binary tree, or can
Is
I,
what
or should
again?
I, the complete binary tree?
Oh, what is the definition of a complete binary tree?
No, just like, could I just draw one out and then just to make sure
Yeah.
I
So,
understand it?
so
Yeah.
there is a drawing mode here that you can actually draw instead of just typing text. You will find that
Oh,
there is a
okay.
button. Yeah.
Uh, can you see this?
Yes.
Okay. So if I have just like 2, 3, 0. Sorry about my drawings.
It's fine.
And then, so this would be a complete binary tree.
Yeah.
Okay.
So
But if
basically,
there
let
was
me
no,
give you a good idea what a complete binary tree is. So if we look at this one here, this is a full binary tree, but at the same time, it's a complete binary tree. Okay. This one here
yes.
is a complete binary tree. This one here,
Mhm.
still a complete binary tree. This one here is still a complete binary tree. But this one is not a complete binary tree. So when
Yes.
like complete binary tree means all levels are complete and the last level is either complete. If it's not complete, it is always nodes from the right. So you cannot ever find a node in the right and then an empty node and then a node in the left. It needs to always be continuously complete from the left.
Okay. So like if with your current example right here, this would never occur as an input.
Yes.
Okay. So I guess that helps a little bit with our search because if uh, we don't have to search the right side if we know that there's no
Yeah. So
right
if
node.
you just if I didn't say it's a complete binary tree, if it's just a binary tree, what is what
Hmm.
would you do in order to count the nodes in this tree?
Um, so just a regular binary tree. So that means it could be, so this would be a valid input and it could be kind of anything as long as it's at most 2. I believe a depth first search,
Okay,
um,
good.
to probably count each and every node. Um,
Yeah. So this is one more hint I want to give you. So if you want to really impress your interviewer, here is what you would
hmm
do in a post like this. You would say like, okay, since this is a binary tree, I can count all nodes using a depth first search, and basically a depth first search would go over all nodes. It will take an n number of steps, or the complexity of n, and it will solve the problem. And it is very easy to implement it just like a recursive function. But since the problem is stated that this is a complete binary tree, then there must be a solution that utilizes this. Even if you don't know what the solution is, just you saying what I just said, in most cases,
hmm
it's enough for the interviewer. And you would say, basically, you would say, okay, I I can implement the recursive solution, and then we can think about how to write a better solution. And most interviewers would say, okay, go ahead with that. Because the idea of you knowing that there is a solution for a problem and there is a better solution for a problem, but you don't know about it yet, in most cases, that's enough, even if you don't find it. Many people
Okay,
go into a problem of trying to think about the best solution and they cannot find it, and they also didn't implement the normal solution, which ends up with the interview ending without you providing any solution. It is a terrible case. Don't ever do that.
got it. So, yeah, like I mean, I've definitely encountered like a situation where I didn't know if it was like the best thing to do because I didn't know if it's like the right thing to do to like say the solution
Mm.
Like there's sometimes where I know it like in my head and I can like visualize it and draw it maybe, but maybe not
Yeah.
necessarily implement it in code at the time.
Yeah. Always in any interview, always state to the interviewer the immediate answer. Like if you already have a solution, even if you know that the solution is not the best thing, just
Hmm.
totally be open with the interviewer. Okay, I have like basically a brute force solution for this problem. I know there must be a better solution. I just didn't think about it yet. Do you want me to implement the brute force? And then leave it to the
Oh,
interviewer to decide. Because it is always better to provide a solution, even if it's not the best, than not providing anything at all.
correct. What if there's so like in the instance, um, say I know the brute force solution, but not the optimized one in terms of implementation? Is that okay? Like, if is it okay if
No,
I'm like, I know how to like visually explain this, but I'm not sure how to implement it in code?
yeah, in most cases, when you implement the brute force solution, and basically
Yeah,
you tell the interviewer, okay, I think I have like maybe a linear uh, approach. I think I would do X and Y and Z. Just giving them the idea would be enough. In most cases, they will not ask you to implement it. So because like here is what we're looking for when we interview someone. We're looking for
hmm,
someone who can problem solve. Okay, if you did what I told you, you already proven that you provided two different solutions. We want someone who know how to code. And in order to test your coding ability, I don't really care if you implement the brute force or you implement the optimized solution because I'm just testing coding ability right now. I'm testing that you write a clean code, you know how to test for like edge cases, you know how to write like conditions for verification of input, stuff like that. You know how to test things like this. So the interview has multiple things that people look at, and if you know those components of the interview, you can basically drive the interview to success because you can provide those different pieces with the best state that suits you instead of just providing all of them in one solution. Because providing them all in one solution is not always straightforward. And that's what you will find in many people who struggle with interview because they know there is like a dynamic programming approach for a problem that solves it in like an logarithmic approach. Like this problem, for example, the very simple
yeah,
solution here is n. There is another
hmm,
solution that's log n multiplied by log n. If you started from the beginning thinking about that logarithmic solution, we could have taken the entire hour and you may not even find it.
yeah,
And that's the problem that I see many people make a mistake in interviews, and you need to pay very good attention to this.
yeah. That's definitely good to know.
And don't worry about all those notes. Like once the interview ends, I would summarize them and send them to you in the interview notes.
Okay, thank you.
So if you want to like just let's think or one more hint I also always give to everyone. If you want to have an interview that's basically much more relaxed, always go into the interview with a mindset that it's not an interview. It's just a discussion with someone who could be your future colleague, and both of you are working on a problem together. If you go with that mindset, it would naturally make you speak while you're thinking, and that feeling of uh, basically ease would transfer to the interviewer, and the interviewer would just be giving you hints without them even noticing that. It would go
Oh,
much
really?
more, yeah. Because at the end of the day, if I'm interviewing someone, I'm interviewing someone that either going to join my team, or like be my colleague or be under me. I'm working in. I'm actually a manager, not an engineer. Basically, if I'm interviewing
Oh,
someone, I'm interviewing someone who would actually work for me. Or when I was an engineer, I'm interviewing someone who would work for me. So we always ask ourselves one question: Can I work with that person or not? So if you go into the interview and give them an answer to that question in the first 10, 15 minutes, it would make them feel much easier to give you hints. It's just psychological. They cannot control it.
Yeah, I didn't think of it that way, but now that you mention it, it definitely makes sense.
Yeah. So let's think about the problem again. Let's look at this tree. This is
Hmm.
a complete. How can we calculate? Actually, let's go one step. If we have a full tree, how can we calculate the number of nodes in a full tree without actually traversing it?
I guess then if we know that it's a full tree, we can just
Hmm?
do half of the tree and then multiply it by two, since we know
We
that
don't
it's.
even need that. If you know that you have a full tree, all you need
Hmm.
to know to calculate the number of nodes is the height, right?
Yeah, correct.
If this height is 3, so the total number of nodes is 2 power 3 minus 1. Basically 2 power h minus 1. In this case, it's 7
Hmm.
nodes. Because on each level, the number of nodes is multiplying by 2. Except the first level, it is 1. That's why we do like a minus 1 at the beginning. So if this is a full tree, the number of nodes would be 2 power h minus 1. Okay? So we know this,
Yeah.
if it's a full tree, that this is what we need to do to calculate the number. What if it is not a full tree? Like basically it is like this. How can we use the fact of that equation to basically calculate how many nodes in that tree?
Um. So I guess that equation, 2 to the h minus 1, that's our upper bound. That's the most amount of nodes we'll have
Yes,
in
exactly.
the problem. Um, so knowing that, we can, and I guess since we have a complete tree, we know that the lowest it could be is something like this, where if um, you remove these middle nodes,
Mhm.
and so this would be our lower bound, where it's like
Yes.
this, this, and this.
Yeah, this would be basically 2
It would be
power
2 to the h, sorry,
2, yeah, 2, 8 to power h minus 1.
plus
Uh,
1.
there is no need to be plus 1, so it's basically 2 power h minus 1, which is 4. H here is 3, so it's 2 power 2, it's 4. So like the minimum
Oh,
bound
yeah. Hmm.
is
Yes,
basically it
it would
can
be
go
so,
from h minus 1 to 2 or h minus 1. That's like the range of number of nodes.
right. So I guess knowing that, we could, and I guess maybe breadth first search might be better. So we'll be kind of going wide on each level,
But if
because
you
it
do
seems like,
a breadth first, you're still going to visit all nodes, so it's still going to be n.
right. Um,
So let me give you a quick hint. How would you know that this is a complete tree or not? You need to compare basically the height on the left to the height on the right, right? If the heights are equal, then this is a full tree. If the heights are different, it's not a full tree, right? So
yeah,
basically, your function for calculating the number of nodes, it will have like two. It will first calculate the height from the left side and the height from the right side, and then it will have like two if statement. If L height equal R height, just return 2 power h minus 1. If they are different, that's the only thing that's remaining on that function to complete the entire problem. What would you do if the height is different?
so if they're different, then we don't care about the right side of that tree or subtree.
So
Um,
why we don't care about the right side?
because we know that it'll be shorter than the left, so there's no point in traversing that right side since we're trying to
We
find the deepest level.
no, we already know the height. So actually, let me tell you like what is the trick in this question. So let me just remove some parts so I can write things here. So if you basically have this logic, so basically you will calculate LH and RH, okay? This is, let's say this
Mhm.
is equal X and this is equal Y. You would have an if statement. If X equal Y, return 2 power H minus 1. We already know that. If they are different, what we would do is we would return 1 plus, we would recursively call the same function and give it node dot left plus node dot right, not writing, dot right. So basically, if the height is different, I would return 1 plus number of nodes in this subtree plus number of nodes in this subtree. The recursive function for the subtree on the left, it would calculate the height from the left, which is 2, the height from the right, which is 2. It would return 2 power h minus 1. It would return 3. So it would be 3 plus 1 plus whatever this function return. This function would calculate the height from the left, it's 2. From the right, it is 1. So it would call the two subtrees again. This one would be 0. This one would be 1. So it would be 1 plus 1 plus 1 plus 3. So it would be 6, which is the correct number. Now, since we are doing a traversing of the tree, each step we are calculating the height. This is log n. And on each step, we are recursively calling the subtree either on the left or on the right, which is another log n. So it's a log n multiplied by log n instead of n, which is much better because if you are talking about a tree that has like a million uh,
Mhm.
nodes, instead of taking like million steps, it will basically take like, so a log of a million is like uh, it's like 30, no, it's not, just like 20 something. So it would be like 600 steps or something like that total instead of a million. Did you
Yes,
understand how
because
it works?
yeah, so basically this implementation is recursive and you would be going through each
Yeah.
half of the
Yeah, there will be two
subtree
functions
each side.
basically. A function that takes a node and takes like a boolean to see if it goes
Mhm.
right or goes left, and it will go depth either to the right or the left to just calculate the height. This is function one. This one is not recursive. Actually, sorry, this one is recursive on its own, but it just calculates the height. And the other one is used to calculate the number of nodes in a subtree. The first call, it would take the root, and if the heights are different, it will take the left subtree and the right subtree and call itself again. Using
Yes.
both of them, each one of them is a log n, and because they are used together, it's log n multiplied by log
So just, one question I had about that runtime. So log n times log n, that's significantly better than n even, right?
n. Yes, because log n of a million is, I think it's like 22 or something like that. So it will basically be
Mhm.
22 squared. It's like 400 and something. If we are talking about a million nodes,
Got it.
it would be like
Mhm.
400 compared to a million.
Yeah, which is a huge saving in
Yeah,
time complexity.
yeah.
Yeah.
Okay, I think that's the last question. So, like, shoot any questions that you have.
Yeah, so just in general, like I guess you kind of elaborated on it earlier, but just so like what did they exactly look for in like a follow-up technical interview like this?
So, generally speaking, like, I can't speak for Facebook because I actually work for Amazon, but uh, basically, I made interviews with Facebook before. So, basically, like, especially
Mhm.
in new grads, like, they would be just looking for what I told you in this in the interview. Like basically
Mhm.
someone who can problem solve, someone who can basically read the problem statement and basically make sure that they understand the question, someone who would ask questions. Like even if you understand the problem very well, just make sure that you understand it very well and ask questions. And you already do that, which is really good. So just continue what you are doing and like the idea of you giving examples and stuff like this is very, very good. Just continue doing that. And basically, no one expect you to like come up with a perfect solution. That's not really the goal of the interview. There is like much important things that we look at. This is like the last thing that we look at. Someone who comes with like the perfect complexity and everything. We look at someone who asks a question, someone who can provide alternatives, someone who understands the trade-offs, someone who can really determine if a problem has like a better solution, even if they don't know what that better solution is. Someone who can speak while they are doing their implementation, basically speak about the idea and what they do. And you're already doing all of that. So this is just very good. So continue doing what you do. And I think if you just continue to do that, you will be totally fine.
Great. Thank you. That really means a lot.
Yeah. I would also summarize all of those points and put them in the interview feedback so you can read them and make sure that before you go to the interview to make sure that all those points and everything.
Okay. Yeah. Thank you so much.
Okay. Any other question you have?
No, I think that was like really my main thing, like just kind of what to expect, what to highlight on my side to make me a better candidate
Yeah.
in the interview.
Yeah. Good luck with that.
Yeah, thank you.
Thank you. Take care. Bye.
Bye-bye.